Thank you so much for being here. We're really excited about the talk we have today. And we also want to thank the conference organizers. This has been really, really awesome so far. And today we're going to be talking about artificial intelligence. I'm sure you've never heard of it. Just kidding. We've all heard a lot about it. But we're going to be going beyond these generalist large language models to talk about how we can fine-tune them and specialize them to improve their accuracy, transparency, and make them work best for our use cases. And we're going to do that with this awesome open source project called InstructLab. And InstructLab is going to allow all of us to be able to tune models without needing to be data scientists with high levels of expertise, because we can do this all from our laptop. So my name is LaGreek Harrison. I'm a developer advocate here at Red Hat. And
I'm Cedric Clyburn, developer advocate at Red Hat as well. And without further ado, let's get started. We've got a really fun demo and experience for you guys today, talking about how you can essentially work with large language models for your specific use case. Because the big question is right now is that we have access to the most powerful AI models. Like, these are incredible, but the thing is, actually integrating them into our personal or business use cases for their specific domain or industry is a little bit tedious, because essentially we're working with these generalist large language models that can do a lot of things. They can work with text, they can be used with RAG situations to give them extra data, and we can use all types of technologies like OLLAMA to start working with these locally or deploy them in a variety of different applications. But the thing is, how do we adapt these models for our specific use case? Because what I want to kind of think about is that there's a lot of limitations right now in this early space of AI. Was anyone here for the last demo of Podman Desktop? Okay, so you might have seen the example that we kind of presented. We're both from the US, and we weren't really sure who won the Euro 2024. And so what we've gone ahead and done is started up this inference server on our local machine to ask a Mistral open source model from Hugging Face who won this Euro 2024. And so what's happening nowadays is a lot of people are using ChatGPT, Perplexity, all these different chatbots to essentially ask and answer their questions. And they're great up until a certain point. So if I was to ask this model that I have serving with InstructLab, we'll talk more about the project in a little bit, but we could say, who won the Euro 24? And because of its training data, its limitations in what it knows, its ability to work with the internet, which would just a variety of different limitations, it's not going to know specifically any information about the Euro. It's not going to know the right information, and it can't give us the right output for our specific use case. Now, we're going to show in this session how we can go from a base model to a trained model on this specific laptop without needing to be a data scientist, and also in an enterprise use case. But I think it's fun to talk about all of the different technologies and models that we can use: ChatGPT, Llama, Claude, whatever it might be, or LangChain for infusing them into our application, Hugging Face for storing models. I think that we need to understand that there's a layer beneath that. There's some challenges that we need to sort out with generative AI.
yes, there are definitely some challenges here. We all love to hype up AI, and it deserves it. It's super powerful. But as Cedric just showed with that demo, it's not always going to have up-to-date information, and it's going to have a couple other challenges. So we thought we'd pull some silly examples to kind of highlight that. So first, right here, we have a chatbot from a Chevy car dealership that promised a user that they could take a truck home for a single $1, no take backsies. And that's definitely going to be against company policy, if not illegal exposure. This is a picture of Cedric and I driving to this conference in that $1 truck. And maybe you guys remember Google's AI recommending to add glue to your pizza to help the cheese stick. Definitely not ideal. You definitely don't want your large language model doing that. And if that's not an example of illegal exposure, then these 20+ cases that are in the courts right now definitely are. Generative AI is coming under a lot of fire. So it's important that we know how we can improve upon it. This here is a case from iTutor where their model was automatically declining 60+ people for jobs, and they ended up having to pay a $400,000 hiring discriminatory lawsuit. And then finally, beyond all those fun, terrifying flashy headlines, we have cost. That's a limitation that's also worth thinking about. We have pre-training costs, and unless you are a company with super deep pockets, you're probably not going to be thinking about pre-training costs, but you are going to think about tuning costs. So how much does it cost to adapt our LLM to specific tests, and then inference costs, so the cost of generating a response from a large language model, and then hosting costs, so the cost of deploying and maintaining a model for inference or tuning. And we have a case study later that's going to give us some more concrete numbers here, because I think we talk about cost a lot, but I think it's helpful to see it exactly broken down in dollars, euros, et cetera. So all of those examples I just went over kind of boil down to 5 categories of the limitations of large language models. 1, knowledge cutoff. We saw that with the Euro Cup example a second ago. The training data can be outdated. 2, a lack of transparency, and this can lead to legal exposures and unexplainable biases, and then false information and hallucinations, right? As well as a lack of enterprise domain knowledge that these large language models have. So right now, only 1% of enterprise knowledge is represented in large language models. So that's a huge opportunity for us to be able to tackle. And then finally, lack of explainability, ethical bias concerns, and difficulty in understanding why AI is giving you the outputs that it's giving you. So Cedric, how can we help generative AI do better?
And I think that's the million, or I guess billion-dollar question now is, how do we take these models that are amazing, right? They can do a lot, but they have these challenges that we need to start mitigating, and help us to and think of ways to start improving these models. What can we give them? What we can tune them with? And this kind of brings me to this kind of chart of all of the different possibilities that are commonly used in improving models, right? The most basic one is prompt engineering, which is, cool job title. I would like that. But that's essentially, giving the model some extra information, some extra context to help produce the intended result. There's things like parameter efficient fine tuning, where you're essentially working with a small subset of the total parameters in a model to essentially guide it in the right direction, but not change the entirety of the model weights, versus full fine tuning. Companies like OpenAI are doing this for ChatGPT, where you're essentially doing reinforcement learning to teach the model bad from good. And within fine-tuning, what we're going to be talking about today is something called an alignment tuning, where you're aligning a model within a certain domain so that it produces the right outputs for a certain context. And this is really, really cool. And I kind of want to break it down a little further, right? Because what we're dealing with right now in the state of Hugging Face and fine-tuning is that we're taking these foundational models and we're adapting them to all types of use cases. If I go over here to, I think I have Hugging Face open, I can show you that if you go over to the kind of models catalog, right now we've got over about 700,000 different models. So 700,000 different attempts, perhaps, to take a model and do some fine-tuning. The issue is, once that happens, what do we do with that information that was used to train the model? How do we contribute that upstream the same way that we're doing with open source projects in the form of PRs and branches, et cetera? So there's a model sprawl right now of all these different fine-tuned models for all these different use cases, obviously, that are really, really cool when we're integrating into our applications, but now we've got this issue of we've got these tuned models. What do we do with that knowledge, those contributions? Within fine-tuning is alignment tuning, and I'll kind of show this as different examples. So for the first off, we're not doing pre-training, but we could be working with fine-tuning as a data scientist to use our computational power, probably more than just my laptop here, to do that fine-tuning. With alignment tuning, what we're doing is we can kind of use technologies like QLoRa, if you've heard of it before, to do a small subset of training on the model so that you have the base context but additional information. And the way we do that training, as you're going to see today, is that we teach the model with a teacher model and a critic model, same as how we would do this in school, where you have a teacher explaining new skills, concepts, and knowledge to a student, but this is in the context of a model, so it can answer questions and it knows the specific domain that it should be in, so that we have more useful results, that we understand training data, et cetera. Very popular right now is also RAG. So taking a foundation model like that Mistral, if you were here for the last session, what we did is we added the news from CNN of the Euro winner, right, to a RAG pattern for this application, where we have a vector database. You pull different documents from that vector database based on the similarity score of what the context is for your question. You pass that back into the response of the model, and there you have a quick and easy way to enhance a model. But what's happening is we're just supplementing the model, right? We're just giving it kind of a crutch so that it knows the information. But I think there's going to be a really cool intersection between different types of fine-tuning and different types of RAG, right? There's different situations for each. Combine both of them, it's going to be huge.
Well, one example that really helped me understand this was to think about a foundation model as an 18-year-old adult, right? They've got a lot of general skills. And then you send that adult off to college and they specialize and they learn something. And that's going to be similar to alignment tuning. You're changing some of the parameters, you're specializing the model. But say that same adult, that same foundation model had a rough upbringing, had some bad luck, and we need some overarching character development. That's going to be more similar to fine-tuning, where we're touching all of the different model weights.
Right. I think that's a great example. And with whichever way you want to choose to do model enhancement, to make your model better for your applications, I think we need to think about starting from the right foundation, starting from the right base to build the rest of your house. So, Legree, I think you have a really good example on why this matters.
Yeah, this is an awesome case study from a PM at IBM working on Watson AI. And it's showing that if you were to work at a company with 700 employees and you wanted to generate one-pager meeting summaries for each meeting that they attend, if they attend on average 5 meetings a day, 30-minute meetings, 500 words in that summary, 3 employees in each meeting, you're going to have a different cost to generate those summaries if you're using a 52 billion parameter model versus if you're doing a 3 billion parameter model that you fine-tuned. So say we use that general purpose large language model that we're all familiar with, 52 billion parameters. Your cost is going to be 0.09 cents per summary, $105 a day to generate all of these summaries for your employees, and then $40,000 a year. But if we were to instead use a 3 billion parameter model that we've fine-tuned for a little over $1,000, we could generate all of those same summaries for a little under $3,000 per year. So this really shows you how important it is to pick the right foundation model for your use case.
Exactly, and that's just thinking about cost, but what about the time to get a result back from the model, et cetera? So the kind of approach that we've taken in collaboration with IBM is that recently, just a few months ago, we released a new set of foundation models. So these are models for working with language and working as instruct models, but also for coding tasks, and I'll get into that in a second because you're going to see that these performance on benchmarks is really, really impressive. And what these are specifically for is made for this type of fine-tuning. So they're essentially the base of a model that you need to just add a little bit of instruction guidance, which is what we're doing with InstructLab as a project today, in a variety of different formats for 8 billion, more parameters, et cetera. And what's really, really important is, first off, they're Apache 2.0. So that essentially means you have full freedom to do what you want with the model. If you've gone on Hugging Face, try to work with Llama 3, you have to sign a little bit of a contract. There's some clauses. Here, you have the full access, right? Red Hat is all about open source. That should also come with the models. And with the same idea, you should know what your model is trained on, right? Even if it's open source, you don't know what's exactly in your model. What we've done is kind of released the entirety of the open license permissible data so you can see what's in the foundation model. And I think this is a huge thing because going forward, we need to know what's in a base foundational model so that we can understand its outputs and better suit it for applications. And so this is really big. And there was a really cool case study also with these Granite models for code. So fortunately, I've never had to code in COBOL, but there was a project where there was a migration between COBOL and Java for an application, enterprise application. What took the span of 11 months beforehand was done with these trained models in 3 days to a week. It was incredible because compared to other different models, these models were trained in 116 languages and perform really well against other models of their size like CodeGemma, CodeLlama, et cetera. So starting from the right foundation, you could pick these Granite models, you could pick Llama, you could pick Mistral, whatever it might be. It's really important to consider what they can do and their licensing so that when you use them in your applications, there's no tricky surprises. So this brings us to the really fun part of the session, and what we're going to show with the demo is how do I take a model, this base foundation model, and contribute information, knowledge, skills to this model so they can perform better, so they can answer better, and that we understand the training data that was used to produce this final output. So we have transparency with our AI strategy. I think it's really huge. Yeah. And we're going to do this on the computer that I'm working on in a matter of a much smaller amount of time than it would traditionally take. We're going to show the process here. The one I trained yesterday took just 2 hours for the data generation, et cetera. But talking about the data generation, any of us here data scientists? Okay, sweet. Do you know the pain of having to collect data, label data, process data? Is it fun? Okay. I feel
it's all thumbs up.
Yeah, depending how you feel. The thing is, it is a really difficult process, and historically has been limited to data scientists to be able to do this function of work with different libraries to process, to have this data accessible for fine-tuning. And I think the future of AI is opening this up to everyone of all skill sets. So us as developers to be able to contribute to these model advancements. And we do that through the Instruct project, the InstructLab project, which essentially defines this folder structure, just like how I'd have on my file system, for adding new information and new context to a model in the form of question and answer pairs. This is all transparent, it's all in YAML. I can understand this, but even if I don't have a development background or data scientist, it's in YAML, so you can easily, as a domain expert in a certain field, add information to a model. But we have that information. The trick is convincing a LLM to think a different way, right? It was trained over months or however long it took. We need a large amount of training data to convince it to think otherwise, to give it new information and context. What's happening with the InstructLab project that we'll show is that we generate a large amount of training data based on that initial pair of answers and questions and answers that you give it. So this kind of makes it a lot easier to generate the information that you need to train the model. And we retrain that with that new synthetic data based on what you initially came up with. There's a way to define, hey, is this good data or bad data? And not only that for training models, but there's also a community aspect to it. Just like how we review PRs and we accept them in repositories, we're doing the same thing with InstructLab as a project to be able to triage these new contributions to models and release this on a basis on Hugging Face, which is really cool. So under the InstructLab organization, you can see the models that the community is contributing to. And I think that's really cool to open it up to everybody to be able to contribute to model development. So without further ado, who's ready for a demo?
Woo!
Woo. Okay, so the goal is to work with this project, right? We're going to generate training data based on the Euro.
Yes, the Euro.
And let's hopefully convince this model and bake in the information into the weights. And that's really efficient because when we're doing RAG, we're giving extra context, we're having to use vector database, we're adding it to the model. This is going to be inside of the weights so that when we're inferencing this model, it's much faster. So without further ado, let's hop into the demo and we're going to show this process. So the first thing is setting up InstructLab, and you can view the project at instructlab.ai. And there's also a repository organization, organization and a repository where you can download the CLI with Python. And so I'll go ahead and show you just that repo here real quick. If you enjoy the talk and you want to try this out, feel free to give it a star as well. But I'm going to go over to my CLI here to show you this whole process. So we were working with that original base model, right? It had limited context. We don't know what it was trained on, et cetera, et cetera. And so what I'm going to go and do is hop into a new project. So we're actually going to hop out of here. And let me make this a little bit bigger, just in case anyone's having trouble seeing it. So what we're going to go and do is create a new folder. And we're going to CD into that and set up a new project, a new directory in order to be able to do this training. So I do an ilab command. And in my Python virtual environment, essentially, I have the ability to kick off the model data generation, or data generation for a new model, sorry, to work with a teacher model that's essentially going to help me generate new data, to be able to convert that into safe tensors and have those model weights, but also to quantize that for a GGUF format so I could use it, for example, like with OLAMA or one of these other inferencing applications. So the first thing I'm going to do is ILab init. Actually, I'll do a config init. And what this is going to do is set up this new structure. So it's going to give me a taxonomy repository. What that means is a directory structure for the new data I want to add. I'm going to go ahead and clone it down from GitHub as this base template. And now in my folder, I've got a taxonomy folder for this new data I want to add, and I've got a config. Let's take a look at the config, because this is really cool. This is how we define how we want to train and fine-tune this model. So we're working with this Merlinite, which is the derivative of Mistral. You could also be using something like Llama or specifically Mistral itself. And we've got some default information about how we want to chat with the model, how we want to generate information, and then how we want to serve this. For example, if I was to serve it right now, it would be on port 8000, and it's using Llama C++ as an inference server under the hood. The next thing we need to do is an ILab model download, right? And what this is going to do is essentially download a teacher model from Hugging Face. And wow, that Ethernet is fast. So we'll be able to generate more of this information to train the model with the help of a teacher model, which is really neat. And so I'll kind of hop out of that just in the interest of time, because what we've got in the other folder is actually this pre-set up structure to show you how the training is going to work. So in that taxonomy for, I'll go back here, CD, hold on. So I'll go to the specific one that we have for this project, the Euro folder. So here I've also got it opened up, this taxonomy for that folder in VS Code, and I'll make this a little bit bigger. But this is what taxonomy means. It's just a way to represent the data that we want to train our model with. So for whatever use case, whatever domain, we have questions and answers that's going to help not only just teach the model, but help it think in a certain way for the context that we want, which is to help us understand who won, right? We gotta figure that out, and no Google. What you'll notice here in the bottom is there's a reference to more information. So I actually have some information compiled from all around the web, but of course you'll want to do this with whatever your data is, whatever your company information that you'd like to provide, et cetera, et cetera. And what's going to happen when I kick off the training process is that it's going to use all that information from the YAML file that I showed you in VS Code, the one right here, and it's going to use that extra information to build out this huge data set that's going to be used to convince the model that maybe someone won the Euro 2024. TBD. So what we're going to do is do a diff, but a special diff. So it's going to essentially check this taxonomy and make sure that our data is valid. So you'll notice that it's structured in knowledge, in skills, etc. And we can define a folder for it, so sports, games, etc. And all we have to do to generate this synthetic training data is do an ILab data generate. By default, it's going to generate 100 more question and answer pairs that are going to be in the same kind of format as this, but it's going to help us train the model based on what we've originally given it. So I just noticed that I need to be serving the model for it to help me. Silly me. So I'll do ILab model serve down here, and we'll wait just a second for that to spin up. So now it's going to be able to help me generate that training data. So we'll do ILab data generate, and we'll see that we're synthesizing new instructions, new training data. We've selected the taxonomy here that I have on the right, and we'll give it just a second here. And this is what's crazy is I'm on a MacBook here. This is old. It's seen better days. But I'm not having to use. I wouldn't have to use GPU in order to generate this new training data. So we're going to generate 100 pairs. This could take up to an hour or something like that. And you'll see as soon as we start generating them is we have brand new questions and answer pairs that we never came up with originally, but now are being added to our project in order to train the model. And so this would go for 20 minutes, couple hours, depending on how fine-tuned we want the model to be. once we generate that training data, it's stored and it's on our local environment. So if I do a ls, we can probably do ls data and see, well, once we have the data, it'll be essentially in a JSON format to be able to be integrated back into the model. So I'll do a lab model train, and if I had already generated all that training data, it's going to essentially start integrating that back into the model weights itself. And so what's really cool is it's able to do this for any type of model, right? Under the hood, it's QLoRa, so a pretty effective way to do this parameter-efficient fine-tuning. And once we do that, we would have the model weights for this brand new model in our local directory. And the last thing we'd have to do is start to serve that model again. So we'll go ahead and I'll stop this real quick. And we'll go ahead and serve this model that we've already trained yesterday to show you exactly how this works. So in my directory, I have a trained folder. So I'll show you right here. We've got the tokenizer. The model weights are gone, but because we've already converted them in a quantized format here. What I'll go ahead and do is I'll chat with the model. So we're going to point to that gguf file that we've quantized with the iLab model convert that we could do. So now we're serving this model. Oh, and look, I'm serving two models. So let me go ahead and stop that. And so now, once that model is being served, this is, this is the big drum roll right here. If I do an iLab model chat,
he would have put it in here. He would have asked who won the Euro, and it would have said Spain. Or you could have done that in Podman AI Lab, which if you were at the last session, it would have shown you.
Who has seen Back to the Future? Okay, good amount of us. Okay, so I'm going to show you just really quick enterprise application use case. What we will do is show you a quick Java application that's using one of these models in an insurance use case. So I'm going to be using Quarkus to essentially spin up this application. So it's an insurance company that needs to be able to use a model to help its agents effectively go through a large amount of different new insurance claims, right? So I'm going to go ahead and serve this on my localhost port 8005. So once this pops up, we'll be able to access it. We're using Olama here. So if I specify the port for one of these trained models, then I'll be able to essentially use a WebSocket that I have here to chat with the model, right? It'll have the context of the insurance claim. Very cool, very fun. So what we're going to go ahead and do is I will hop out of this Euro example and hop out to a pre-trained model. So if I go to InstructLab, what we're going to go ahead and do is serve a pre-trained model here on port 8000. Now, what data was this trained on? I'll show you real quick. The DeLorean has a flux capacitor in the movie, but I just learned it doesn't exist. What we could do is tell and teach the model that this does exist in the context of this insurance claim organization. So back in this repository, we see that there's a tiny bit of information that we want the model to know, that a flux capacitor for time travel is $10 million. So by training and serving this model that we have locally or that we could deploy anywhere on edge environments, Kubernetes, et cetera, we can ask the model, how much does a flux capacitor cost for this specific claim? And what's really neat is if I was to use Mistral, Llama, any of these base default foundation models, we wouldn't be able to know because it wasn't trained on that data. And if I refresh and I ask this model, how much does it cost? Based on that training data that was in the taxonomy document, it's going to know the new cost. What we can do with these models is fine tune and train them. And if we want to deploy them in production environments, there's support for that with RHEL AI, which is a brand new way to serve, host these models, and keep them really close to the actual hardware in the form of bootable containers so that you can take advantage of hardware acceleration, et cetera. But I'll pass it over to Legree. And
yeah, try InstructLab for yourself. Join the community. This is the organization's GitHub page, and you can get involved, join our Slack, join our mailing list, follow us on socials, and use InstructLab. Thank you guys so much for your time.
Thanks.
Woohoo.